Hello. In this video, we'll explore logarithms. We'll cover their definition, the fundamental rules they follow, and what their graphs look like. First, what is a logarithm? A logarithm answers the question, to what exponent must we raise a specific number called the base to get another number? This relationship is expressed as log base b of x equals y, if and only if b raised to the power of y equals x. Here, b is the base, which must be positive and not equal to 1. X is the argument, which must be positive, and y is the exponent, which is the value of the logarithm. For example, the logarithm base 2 of 8 is 3. This is because 2 raised to the power of 3 equals 8. Now, let's look at the important rules or laws of logarithms. These rules help us manipulate and simplify logarithmic expressions. First, the product rule. The logarithm of a product is the sum of the logarithms. Second, the quotient rule. The logarithm of a quotient is the difference of the logarithms. Third, the power rule. The logarithm of a number raised to a power is the power times the logarithm of the number. Fourth, the change of base rule. This allows us to change the base of a logarithm to any other base k, often base 10 or base c. Fifth, the log of 1. The logarithm of 1, for any valid base, is always 0. This is because any base be raised to the power of 0 equals 1. Sixth, the log of the base. The logarithm of the base itself is always 1. This is because any base be raised to the power of 1 equals b. Here's a quick summary of these essential logarithm rules. Finally, let's look at the graph of a basic logarithmic function. Y equals log base b of x. We'll set up our coordinate axes. Remember, the logarithm is only defined for positive values of x. Let's consider the case where the base b is greater than 1, like log base 10 of x, also known as the common logarithm. Notice some key features. The domain is x greater than 0. The graph only exists to the right of the y-axis. The range is all real numbers. The graph goes down to negative infinity and up to positive infinity, although slowly. It always passes through the point 1, 0, because log base b of 1 is 0. And there's a vertical asymptote at x equals 0, the y-axis. The graph gets closer and closer to the y-axis, but never touches it. Now, what if the base b is between 0 and 1, like log base 1/2 of x? The graph is decreasing. It still passes through 1, 0, and has a vertical asymptote at x equals 0, but it slopes downwards from left to right. So, that's a brief overview of logarithms, their definition as the inverse of exponentiation, their useful rules for manipulation, and the characteristic shape of their graphs. Understanding logarithms is crucial in many areas of math and science. Thanks for watching.